Chapter 8, Air and Air Pollution. In this 10-minute lecture overview, we're going to talk about the atmosphere. We're going to talk about types and sources of air pollution, effects of air pollution, and controlling air pollutants. Indoor air pollution I'm going to leave out of this particular lecture. It's pretty self-explanatory once you go through the chapter and the notes what that's about, so I'm going to leave that section for you guys to review yourselves. Before we can have a discussion about pollution, we have to understand some basic things about Earth's atmosphere. The atmosphere is essentially a gaseous envelope that is surrounding the Earth. It's mostly made up of nitrogen. That's the number one piece of the atmosphere, as it were. Oxygen is also sort of the secondary largest gaseous particle in the atmosphere. Together, those two things make up 99% of the dry air. So that's basically all that's there. What's left? 1% for other gases, and also things like water and actually traces of air pollutants. The atmosphere is divided up into layers, per se. The layers go from basically, as you get from the surface of the Earth to higher and higher and higher out towards space. So again, here's what the atmosphere looks like. Mostly nitrogen, some oxygen, and a little tiny bit of everything else. So I'm not going to go into a great deal of detail on the different layers of the atmosphere. Pretty much the one that you should be most familiar with is the troposphere. That is the layer of the atmosphere that's closest to our surface. This is where we have our weather occurring. This is where we're going to see different types of pollutants gather. So this is the layer that we're going to talk about the most. We'll talk a little bit about the stratosphere as well in a future chapter when we talk about the ozone layer. But essentially, most of what we're going to discuss happens here in the troposphere. So what does the atmosphere do for us? It's a great thing. It protects us from solar radiation. We've got all kinds of different types of radiation coming from the sun, things like ultraviolet radiation and X-rays, other types of cosmic rays that could be dangerous. The atmosphere protects us from those things. It keeps the Earth's temperature within a living range. It's a nice and kind of comfy thermoregulator. So we're not too hot, we're not too cold, we're just right. Organisms depend on the atmosphere. We could not live on this planet if we didn't have an atmosphere. And organisms are actually capable of both modifying and balancing the atmosphere. So plants and animals, through the process of photosynthesis and respiration, essentially exchange oxygen and carbon dioxide in and out of the atmosphere. So big point number 2, what is air pollution? Air pollution are different types of chemicals. They can be gases, they can be liquids, they can be solids. They're present in the atmosphere in levels that are high enough to be considered harmful. Harmful to whom? Harmful to anybody. Harmful to humans, harmful to other organisms, or even harmful to materials. They come in two different varieties, what we call primary pollutants and secondary air pollutants. Primary air pollutants are those chemicals that are directly deposited into the atmosphere. Secondary air pollutants are actually chemicals that form when they react with each other or when a chemical reacts with a natural component of the atmosphere like water vapor. So we have a whole host of different types of primary and secondary air pollutants. Primary air pollutants, things like carbon monoxide, carbon dioxide, nitrous oxides, sulfur oxides, hydrocarbons and particulates. A lot of acids are what we have in the secondary air pollutant categories. We have sulfuric acids and nitric acids and those types of things. So when we're talking about air pollutants, we usually can kind of break them down into particulate matter is one major category, and then smog is another major category of pollutants. So let's talk about particulate matter first. They can be solids, they can be liquids, and essentially what they are is they suspend and hang in the atmosphere. So they're little tiny particles that just kind of sit there, and they're light enough that they can float in the atmosphere, sometimes for quite some time, weeks, days, months, years before they settle out. Not all of them are human-made. Volcanoes can actually create some of these particulate matters. Soil particles, so when dust gets kicked up, those can fly up in the air. Even things like soot when a tree burns. But some of these are also things that actually are man-made. Particulate matter is dangerous. It can reduce light visibility. It can corrode metals and buildings and sculptures. Inhaling them into the body actually can cause problems for your lungs, because the smaller the particle is, the deeper they get into your lungs and the harder it is for your body to actually get those out. Particulate matters, these are just a list of different types: nitrogen oxides, sulfur oxides, carbon oxides, things we've talked about, hydrocarbons, what we call HAPs, which are hazardous air pollutants. And there's a nice table here in your book that sort of summarizes these different types of particulate matter. And again, some of these are primary pollutants, some of these are secondary pollutants, but they're all different types of pollutants that we would categorize again as being part of this particulate matter category. And I mentioned not all outdoor air pollutants is human generated. Volcanoes can release different types of particulate matter. Even plants are capable of producing different types of toxic chemicals when they're stressed. The majority of these, however, are coming from human generated sources, mostly transportation. Second would be industrial sources. So if you were to categorize where all these pollutants are coming from, the transportation sector is by and large where they're coming from. It's from the burning of gasoline, the burning of fossil fuels. And fuel combustion itself has a whole other category. This is things other than vehicles. So these would be things like tractors, for example, or combines, or any type of combustion engine that's being used not in a vehicle. And then industrial processes and miscellaneous make up for the rest of the pollutants that we see. So what's so bad about air pollution? What does it do? Well, it harms things. It injures organisms. It reduces visibility. It attacks materials. It harms our respiratory tracts. It can worsen existing conditions. People who have asthma or lung disease or cardiovascular disease are at a greater risk when the amount of pollutants in the air is higher. Their conditions actually can worsen. It can reduce our productivity of crops because, again, it reduces visibility and reduces the amount of light that's reaching the surface, and the light is what plants need to grow, and it's also involved in a variety of other things such as acid deposition, which is acid rain, global warming, and ozone depletion, which we're going to talk about in the next chapter. So here's health effects of several major air pollutants. Okay, again, we've already talked through some of these. The other major type of air pollution that we talk about actually occurs in urban environments, and that's what we call smog or phytochemical smog. And there actually is a difference between the two. So if you're in an urban area and you see sort of a haze to the sky, a brownish haze, it's for one of two reasons, and it kind of depends on the time of year. If it's winter time and you see that haze, it's probably industrial smog, and that's related to coal combustion. So coal burning power plants are burning coal, releasing particulate matter up into the atmosphere. It creates sort of like a haze in the sky. And again, it's worse in the winter because that's when we need more electricity to heat our homes. Phytochemical smog is the type of smog that you see in the summer on a nice hot summer day when the air is really heavy and there's not a nice breeze blowing. You see this haze that just sits over the city. That's phytochemical smog. And what that is that's basically from cars. Because of the high light in summer, the higher amount of sunlight, we have more of those chemical reactions that are producing this secondary phytochemical smog. So again, coming from all these sources, it comes from dry cleaners. They're another source of phytochemical smog. But again, mostly we're talking about vehicles in this case. So what do? How can we combat all of these pollutants? Well, technology already exists to deal with air pollution. Coal-fired power plants have had to use a variety of different technologies as the years have gone on, and the EPA has demanded cleaner and cleaner standards from these power plants. They have to have their smokestacks that have basically scrubbers and filters and precipitators. All of these different things are just different physical means and sometimes chemical means of reducing some of these air pollutants. We can make sure that we don't kick up a lot of dust when we are excavating places. We can increase fuel efficiency to reduce the amount of fuel being burned. We can use low sulfur fuels. We can modify engines to make them more efficient. We can reduce spills of different types of chemicals. So this is just showing you how one of these precipitators work out. And essentially what it is you're basically charging the particles. You're giving them a negative charge, and then the precipitator walls have a positive charge, and what happens is the two oppositely charged the particles have one charge and the walls have another charge, and so the particles stick to the walls and then they fall out. So it takes really dirty smokestacks and turns them into something slightly cleaner. That's kind of the idea behind these precipitators. So a piece of important legislation that I want to discuss is the Clean Air Act. And the reason why we have all of these technologies in place to try to help clean up the air is because of the Clean Air Act. It was enacted in the 1970s. It's been updated and amended a few times, and it has greatly improved the quality of our air. We have less lead, less particulates, less carbon monoxide, oxides, ozone. There was a 98% decrease in lead between 1970 and 1990, and that was just due to getting rid of leaded gasoline. So we have a whole host of things that have decreased since the introduction of the Clean Air Act. The one exception is particulate matter. The amount of particulate matter has actually kind of stayed constant or perhaps even gone up a little bit. The reason for that would be just the increasing number of automobiles on the road. In developing countries, just a quick note, while we're making great strides here in the United States and other developed countries, the developing world is having some problems. They want to provide basic services for their citizens. And so one of those basic services is electricity. And the cheapest way to get electricity is coal. And so those coal fired power plants that they have are excessively dirty because it's old technology. The old technology is cheap. They can afford it, but it also is incredibly, incredibly dirty. In these countries, they don't have air pollution laws. And if they do, they're certainly not enforced because what we have is we have a desire for development and industrialization in these countries, and they don't want something like air pollution laws to hold them back. So the problem in these developing countries, China is a good example, India is a good example, is you have rapidly deteriorating air quality standards because of their desire to industrialize. It's also because of the number of the automobiles that they have that are using lead gasoline. They're old cars. They don't have the same type of pollution control devices that our vehicles do. Just a quick note that the leading cause of death for children worldwide is actually respiratory disease. That just goes to show you the the problem worldwide that air pollution really is. We don't think of it as being a big a problem here because we again have these types of standards to keep our air clean, but in the developing world and worldwide, that's what's most likely to cause a child under the age of 5 to die is actually respiratory disease. And again, this is just kind of showing you that in many parts of the developing world, we're putting up smokestack versus smokestacks. They're everywhere, and these again are all places that are generating electricity for the developing world. That's it for this chapter. Like I said, I did not specifically cover indoor air pollution in my 10-minute lecture overview, but please make sure that you go back through my notes and that you review that as well.